JSON is a pervasive format. Many end-user programming tasks require working with JSON, wrangling it from one format to another, or building interactive applications atop it. But end users are impeded by the indirectness and steep learning curve of textual code. We present Sculpin, an environment that lets users program JSON through direct manipulation interactions. Sculpin is versatile. It can be used to transform JSON between formats, as well as create interfaces atop it. We'll now show 3 examples of Sculpin in use. This is a JSON response from an art festival's website listing exhibitions at locations. We want to turn this into GeoJSON so we can map it with an online tool. Our first goal is to get titles into the location object. We select the first title and press Command A to generalize to the title of every exhibition. Sculpin shows an alternative generalization to all the fields of the first exhibition, but the default is what we want. Next, we drag the title into a location object. This moves the title into the first location of each exhibition. We want it in every location, so we click this handle to generalize the target of the drop. Now we can drag the location to the top level and apply a template formula with GeoJSON's key names. We paste the GeoJSON into an online tool and get the map we need. Sculpin has recorded our actions into a timeline. Dropping new data as input will rerun the program to produce new output. Sculpin doesn't just sculpt data into new data, it can also sculpt it into interactive interfaces. Let's make an interactive art gallery. The input to this program is a term to search for. From this, we generate a URL for the Art Institute of Chicago's API and load an API response in place. We select parts of this data, the same way we did before, and apply styling actions to them. We also style the original query as a text box. Now, in run mode, changes to the text box propagate to the search query in the input data. The program reruns and shows new art. This to-do app is more complex. It's got a programmed button and is backed by a persisted JSON document. To make the app, we sculpt it from the data, applying styles and turning values into interface elements. When we group by assignees, keys are attached to the groups with scratch space. To program the button, we enter record mode and act out what should happen to the backing data when the button is clicked. Finally, we enter run mode and have a working app. In our paper, we analyze Sculpin with the Technical Dimensions of Programming Systems framework. Our analysis highlights the advantages of Sculpin's tight feedback loops, while pointing to unresolved challenges around editing programs after writing them. Sculpin's design is guided by 3 commitments. Steps in Sculpin are small and precise, not inferred. They are general purpose and open to reappropriation. And they operate on JSON itself, rather than on a limited intermediate representation. These commitments may make Sculpin's design adaptable to new media. For instance, here's a sketch of an imagined system, much like Sculpin, where users can easily tailor web pages. Opening links creates a network of pages that can be sculpted as a single medium. We hope Sculpin's design approach can bring direct manipulation programming to diverse end-user contexts, beyond JSON.